Welcome back to GateX AIML. So today we'll start with a new concept called as discrete probability distributions. In this specifically, going to see already you have learned the random variable with the discrete probability distribution overview, like how to calculate the probability mass function, expected value, joint PMF, everything, and then conditional expectation and conditional PMF. So now we'll see some standard discrete probability distributions. Standard means already they exist, so they are already given. So why we need to learn them? So in your syllabus, we basically learn three important discrete probability distributions. First one is the binomial distribution, second one is Poisson distribution, third one is discrete uniform distribution. Now before going to that, let us understand what is that we are doing. So if you remember second chapter, the statistics, I have explained you what is the population, what is the sample. Now we'll see in that context what is this distribution, like for example binomial or Poisson, everything, whatever you are going to learn, how it is going to help you. Okay, let's start. So let us say there is a process. So process means some random experiment. Okay, this process generates some data. So this data is the entire data, whatever it generates. Let us say it's a population. A process generates data, so that's we call it as a population. Now, for example, say that you are tossing a coin. You are tossing the coin 10 times. So that is a process. Now it generates set of outcomes. Okay, set of outcomes. So that let us call it as the data. So that entire data, the population. Now, from this population, let us say I want to calculate, say, E of x, that is expected value, and the variance for this data, this entire population. Now, you remember, I told you it's not possible to collect the entire population. The population data may be very big, practically infeasible to collect. There are many reasons. So for that reason, what we have done, we took some sample. Using some sampling strategy, we took a sample. And then we calculated, say, on the sample, we calculated the sample mean and the sample variance. Right? Now, then the entire probability concept, what it says, the measure, how good is this? That is what you understood in second chapter. Now, when you calculate this or this, that is sample mean or and sample variance. How you are going to calculate this is the question. How did you calculate this? See, for all the data, it is not, the mean means it is not sum of all the numbers divided by total numbers. See, always you cannot apply something like this. It can be applied, this can be applied only when we know this follows certain distribution. Means what? This sample or this process that has produced data has some properties. The data has some certain properties. It follows certain properties. If you understand that properties or characteristics, that we call it as characterization. So if you understand what are the characteristics of this data, then I can easily calculate this and it will be accurate. Even I can calculate this, okay, but I don't know whether it will be accurate or not. Why? Because the data may not follow this process. So what it means is this applies, I told you, when this distribution is symmetric. This applies when the distribution is symmetric. That means your central point is here, central tendency, that is mean, for example. Now suppose it is skewed, the distribution is skewed. See, I cannot apply the summation of this, no, because I will not get the exact value. So for this reason, so people have understood, analyze certain processes in the nature or in the real world, certain processes in the real world, and they have identified, they follow particular characters, they follow some properties. So based from those properties, they call it as certain distribution. So for example, say that I have tossed the coins. I have tossed a coin 10 times. Now if I ask you to calculate how many, for example, I want to calculate at least 3 heads in 10 tosses, at least 3 heads. Now what you will do, you know how the data is generated. You will write the sample space and go on finding it. But if I tell you there is a method, someone has already derived it, someone has already given this process, how it works and what are these properties. If these properties hold on this data, any given data, if those properties hold, then that data is generated from that process itself. So if you know that that is the process and the data is coming from that particular process, then we can apply some standard distribution. Standard distribution means for that particular process, they have created some distribution. That distribution will have all your mean value, variance value, median value, everything you can easily calculate. So if I give you, for example, in the same example, tossing coin 10 times, if I ask you to find at least 3 heads in that, then it will be difficult for you to find out everything. But if I say, if I give you a formula kind of thing, if I give you already a result, if you apply this formula, you will get your answer. Then it will be easy for you, right? So that means what? This process, tossing a coin, the experiment follows certain process and properties. If I know these are the properties of the data, then easily I can apply a distribution. That is the concept of the probability distribution, why you apply it. So once you get the same sample, I need to understand like characteristics of the sample, from what process it and what properties it has. Then only I can properly characterize or calculate the correct or accurate mean and variance kind of things. Okay. I hope you got this point why you are learning this. The first standard discrete probability distribution is binomial distribution. Before going to that, we should understand something called as Bernoulli trials. What is this Bernoulli trials? See, if I toss a coin, so I will get either head or tail. See, there are only two outcomes in a Bernoulli trial. So when I toss a coin, there are two outcomes. One is head or tail. So such a trial is called as a Bernoulli trial. Such an experiment is a Bernoulli experiment. Now, similarly, testing items on an assembly line. So defective, non-defective. So there are only two outcomes, positive, negative. Okay, that is called a Bernoulli trial. So either success or failure, passing the exam or failing the exam, hitting the target or missing the target. Okay, heads or tails. So that is called as a Bernoulli trial. So it comes out from the Bernoulli process. We call it as a Bernoulli. What are the properties? So each trial has exactly two outcomes. That is, one is success or failure. That is defective, non-defective, pass, fail, like that. Probability of success P is constant across the trial. This is very important point. See, for example, let us take the coin toss for tossing a coin. So every time the probability of head is 1/2 only. So if I take a coin, so I will toss it once. So probability of getting head is 1/2. I will toss it 10 times. Will this change? No, this will not change. So second property is the success probability, that is getting head here in this example, is constant across all trials. If you toss 100 times, 1000 times, the probability of getting head will be 1/2 only. And each trial is independent. So the first trial is not dependent on any other trial. Similarly, any other trial is not dependent on any other trials. If tossing a coin fourth time, the outcome doesn't depend on the fifth trial or third trial, right? That is independent. So experiment consists of fixed number of repeated trials. So tossing 10 times, tossing 100 times. So fixed number of repeated trials, Bernoulli trials. So if you have n Bernoulli trials, that means if you're tossing a coin, say n times, then it becomes a binomial distribution that follows a binomial distribution. So what it says, very simple, number of success x in n independent Bernoulli trials. Success probability p and failure probability is 1 minus p. So since it's a discrete, we will call it as a probability mass function. So this is important. If I give you this one, is it not easy for you to calculate? Yeah, I know this tossing coin follows Bernoulli's properties. That means it is coming from the Bernoulli process. So if I want to find some probability value, or if I want to find some average, variance and all, and if I know the data is following binomial distribution, then definitely I can apply this formula and get it. You need not sit and analyze and calculate it. So that is the use of the standard distributions that already exist. So the probability mass function is given as, you already know, probability mass function is written as P of x equal to x is NCx to choose x items out of n items, that is n trials x. P power, that is success probability to the power x, then into q n minus x. So q is equal to nothing but 1 minus p, okay, failure probability q. So mean is given as mu equal to number of trials into the success probability. Variance is given as n into success probability into failure probability. Okay, I'm not going to derive this using the definition of mu and sigma square. You can easily derive. Given this is the probability mass function into f of x. Now, how to identify given question is a binomial problem. Okay. So if you observe certain keywords here, fixed number of trials, look for phrases like out of 10 attempts, out for 20 customer, tested 5 items, tossing 10 times, like that. Each trial has two possible outcomes only, success or failure. So instead of success, failure, they mention it as defective, not defective, pass, fail, 0, 1, survive, die, hit or miss, something like this. Only two outcomes are possible. One is success probability, another one is failure probability. And then as I defined in Bernoulli trial, I told constant probability of success P in each trial. The P will not change in each trial. It remains same for all the n trials. If you see probability 0.3, each has a 60% chance. Then each are independent trials. Each trial is independent, or the question implicitly says these are random experiments, means each trial is random. So is not dependent. Question asking like exactly x successes, at least x successes between A and B. The keyword here is successes, means there are only two outcomes, success or failure. That is how you have to understand. Okay, let us take some examples, you'll understand it. A fair coin is tossed 5 times. Find the probability of exactly 3 hits. Also calculate mean and variance. If this question, you can solve it. You already solved for 3 tosses, right? So you wrote the sample space and then you calculated. Now, if I give you 100 tosses, how will you calculate? It is difficult for you to analyze it and calculate, right? It's not feasible also. So for that, you try to model this problem to some distribution. Any problem you get in real world for analyzation, you model it to some distribution and then study those characteristics. So what it says, a fair coin is tossed 5 times and the probability of exactly 3 heads. See, how will you say that it follows Bernoulli trials? See, it is tossed 5 times, the first thing. So n is equal to C. Only thing is calculation is easy, applying formula is easy, but only thing is in the question, you have to identify which distribution you have to apply. So you are going to learn some 6-7 distributions in this classes. So when a random question is given, you have to understand which one I have to apply. Once you are perfectly identify which distribution do I have to identify, then there is no issue. You already know the formula, just get it. N equal to 5. Okay, it is tossed 5 times. exactly 3 heads. They are asking P of X is equal to 3. Now, how will you say it is a Bernoulli trial or it follows binomial distribution? The probability of getting head is 1 by 2. There is probability of getting tail is 1 by 2. If you observe all this data, see there are only two outcomes. Two outcomes, and this probability 1 by 2 is fixed for all the trials. And then there are 5 trials. Is it not Bernoulli trial? Is the binary? Yes, yes. So each trial is a Bernoulli trial because the probability is constant in each trial and there are only two outcomes. So head, tail. So exactly 3 head means they are saying X is the random variable with number of heads, represents number of heads. So number of heads should be equal to 3. How will you find? So this follows binomial distribution. So you have P of X equal to X is nothing but NCX into P. P is success probability. What is success here? Getting head is a success. Okay. P power X into Q. It is tail, right? N minus X. How many trials? 5 trials. Out of that you choose X. 3. 3 heads has to be chosen. Then success probability is getting head 1 by 2. X is 3. Then 1 minus 1 by 2 is 1 by 2. That is getting tail, failure probability. Failure means what? If I won't get head, that's a failure, right? If I get head, that is a success. N is 5, 3. This is 2. So if we calculate, we'll get it as 5 by 6, 5 by 8. Okay. 5 by 6. We just calculate it. Now, what is the mean? I already know N into P. That is N is 5. What is P? 1 by 2. So this is 2.5. So once I understand the problem and apply, it becomes very easy. No? You just apply the formulas and get it. Variance is NPQ. So 5 into 1 by 2 into 1 by 2. This is 1.25. Okay. One more example. A machine produces bulbs with 10% defect rate. So let us say defect rate is my probability of success 0.1. So they want to find exactly 2. Exactly means X equal to 2. If there are 8 bulbs, they are saying choose out of 8 bulbs, how many? What is the probability of 2 bulbs being defective? Okay, what is Q? 0.9. So P of X equal to 2 is 8 C 2 into 0.1 to the power X. X is 2. Then 0.9 to the power N minus X is 6. That is the answer. The only thing is calculation part here. The important thing here is to identify the particular distribution. Next, a student guesses. All these questions you have solved, similar questions you have solved before. There you calculate the entire sample space and then you have calculated all the probabilities and then you applied something and you got the answer. But if I know that follow certain process, it's very easy, right, to solve. So I've taken this example so that you can appreciate. Same question you have solved before. So now the student guesses 10 multiple choice questions. So n equal to 10. 4 options each. Okay. What is the probability of exactly 4 correct? Why it follows Bernoulli trials or binomial distribution? Okay. Answering a question correctly, P of C, or let us say probability of success is 1 by 4, 1 or 4. 1 correct option out of 4 options. Similarly, Q is equal to 3 by 4, 1 minus 1 by 4. Definitely it follows what? Bernoulli trials. So all 10 questions are independent here. So you have to find P of X equal to 4. That is NC4 into 1 by 4 to the power 4 to 3 by 4 to the power 6. So this comes out to be 0.145. So what is mu value? Average number of correct answers will be n into e. So it is 10 into 1 by 4, 2.5. Next. So sigma square is equal to np cube. Is 10 into 1 by 4 into 3 by 4. So variance of this will be 5 by 8. So standard deviation, if they ask, square root of this. Okay. Next. Probability of passing final exam is 0.6. Passing p equal to 0.6. 12 students means n equal to 12. Okay. The failure probability is 0.4. Now, see that what they are saying, at least 8 pass. So they are saying p of x is a random variable representing number of passes. At least 8 means greater than or equal to 8. Not directly, you cannot apply PMF here. How will you calculate this? Again, if you remember that number line. So 1, 2, up to 8, 9, 10, 11, 12. Let us say 12 students. Greater than or equal to 8 means what? This point, this point, this point, and this point. So to add all those. This will be what? P of x equal to 8 plus P of x equal to 9 plus P of x equal to 10, P of x equal to 11, and so on, plus P of x equal to 12, all 12 students. Okay, so this will give you the P of x equal to 8, you can calculate, right, using binomial distribution. So in the problem, you calculate all of this, there is no shortcut for this, then get the final answer. Okay, just okay. Such big questions will not be asked in the exams, but at least you should know what is that, how to calculate here, how to calculate. Such kind of problems I already worked out in chapter 3, I think, or 4, chapter 4. Next. Between 4 and 9 pass. Just I want to show you what kind of questions can be asked. 4 less than or equal to x less than or equal to 9. Between 4 to 9 means this is what I have to find. 4 to 9 means again 4 to 9. So 4 p of x equal to 4. So on up to p of x equal to 9. Till this point you have to find. Next. Exactly 6 pass. This is direct. X equal to 6. Exactly means equal to 6. You can easily calculate p of x equal to 6 as 6, 12 c6 into success is 0.6 to the power 6 into 0.4 to the power 6. Okay. Okay, thank you for watching. Please subscribe, like, and share. Next, we'll start with the Poisson distribution.